Okay, now that we have seen how two lines can interact, all right, now we can take a look at how a line as well as a plane can interact. So let's take a look. There are three cases here. First case, if a line is not parallel to a plane, they must surely intersect at a point. Second case, this is the first case, this is the second case. Second case, if the line is parallel to the plane and they do not intersect. If you take a look at this is the plane, this is the line, they are parallel and they will never intersect. The third case is a line is parallel to the plane and lies in the plane itself. So every single point on the line lies in the plane. Right? Every single point on the line lies in the plane. So there are only three cases if you have a line and a plane, how they interact. So if a line is not parallel to the plane, we're talking about the first case here, they will intersect at one point. Right? That this is the point. Yes? And the position vector of this point will satisfy both the line, because this point, this special point, lies on the line as well as lies on this plane itself. So clearly the position vector will satisfy both equations. So in order to find this position vector, all we need to do is to solve simultaneous equations. Right? Let's demonstrate it in example 5. The line of equation, this one is the equation of a line, all right, intersects a plane with this equation. Find the coordinates of P. All right, find the coordinates of P. So this diagram is like that. The line, all right, this is the point P. This is the point P. Lies on the line as well as lies on the plane itself. So I think you learn in chapter 4. Okay, we can rewrite the equation of a plane like this. This is this one is the Cartesian form, vector equation form. We change it to r dot n form. This is a lot easier to work with. And now we write the equation of the line like that. So this r, whatever the position vector of P is, must satisfy plane as well as line. Right? So all we need to do is to substitute the equation of the line into the equation of the plane here. I think it's quite easy. Alright, so let's write it down. Therefore, you get 5 minus 1 minus 7 plus t 2 minus 1 minus 2, this whole thing, dot minus 1 to 1 equals to minus 2. Sorry, this handwriting is really horrible. Oh, sorry. Eraser. This is minus 2. This is, maybe I just emphasize a bit. This is this part. This is this part. Alright? The equation, this part, the r must satisfy, the position vector must satisfy both equations. Alright? So let's do that. And then I'll go to the next part. Then we just dot. We know there's this distributive property of dot product. We just dot here. 5 minus 1 minus 7 dot minus 1 to 1 plus t 2 minus 1 minus 2 dot minus 1 to 1 equals to minus 2. My handwriting is horrible. But anyway, okay, so you perform the dot products. I don't think it's a big problem. This dot this, you will get minus 12. Oh, sorry, I don't even need to write. It's there. Alright, you perform this dot product. Maybe I beg your pardon. Let me do this. This dot this, you get minus 12. This dot this, you get minus 6. Then you get t equals to minus 2. What does t equals to minus 2 means? It means that when t equals to minus 2, when you substitute into this, back into the equation of a line, right, that gives you the position vector of this point P. Right, you substitute it, you realize that P has coordinates 1, 1, minus 3. Just take note of what they want. They want coordinates. So we give coordinates, not position vector. These coordinates. Yes? Alright. Let's move on to the second example. The next example, example 6. The position vector of 2 points A and B are given by this, and usually we will write it in this column vector form, this one in column vector form. Yep. Find the position vector of the point where AB meets the XY plane. AB meets the XY plane. Actually, it's similar. Example 6 is similar to example 5. It's just a little bit more work, whereby you need to find the equation of AB and the equation of the XY plane. Once you find these two, you can solve, and that's it. It's the same as example 5 earlier. So, I think we can start by finding the equation of the line AB. I do not need to elaborate because this is covered in vectors 4 to find equation of a line. Alright, this is a position vector of any point on the line. In this case, this is OA. You could have used OB as well, and you will give it will be the same thing. Alright, and this is the vector parallel to the line AB. In this case, it is AB. So I don't want to go through how we get this one. Now, you're supposed to solve it with simultaneously with the XY plane. Now, what is the equation of the XY plane? I think you've learned earlier in vectors 4, right? If you have XY plane, I try as much as possible to draw for you. XY planes means it contains the x-axis as well as the y-axis. Sorry, x-axis as well as y-axis. So which means the normal vector is actually the z-axis. The normal vector is actually the z-axis, which means it can be 0, 0, 1 here. This is the normal vector. This is the normal vector of the xy plane. Now, could you have used 0, 0, 2? Fine, that's fine as well. You can use 0, 0, 2. 0, 0, 3, 0, 0, 10, it needn't matter. But of course, we use a more convenient number, 0, 0, 1. So, then, since the normal vector is 0, 0, 1, and obviously, since it contains the x-axis and the y-axis, it contains the origin. So, this one equals to 0. This is the equation of the xy plane. So once you have that, then it is similar to example 5. Alright, you can just solve simultaneously. This one, you substitute this into the xy plane. Alright, and we can get the answer. We can get s equals to, we solve, we get the value of s. You substitute s back into here, you get the position vector of the point of intersection. All good? Yes, so example 5 and 6 are similar, except that example 6 you have to find the equation of the lines. Just a quick note, not all lines intersect in a plane. Some lines don't, because as you can see in example 7, alright, where you have this case where a line is like that, I try and draw, and the plane is like that. The plane is like that, this is the line, this is the plane. They do not intersect. Alright.